For number 2, it tells us that AB and CD are equal, which means they're congruent, and they both have a length of 14. Because they both have the same length, that means that both of these chords must be equidistant from the center of the circle. If they're equidistant, that means that EF will be congruent to EG, as long as they're both perpendicular. Because they're perpendicular, that means that they are equidistant, and we can just set EF equal to EG. 3x minus 2 equals 7x minus 10. I'll add 10 to both sides, and I'll subtract 3x. So x must be 2. It then asks us to plug in x back into FE. If we plug in 2, 3 times 2 is 6, minus 2 is going to be 4. For number 3, it's asking us to solve for x. Again, it tells us that IH is 10 and JK is 10. Since those chords are both congruent, or equal measure meaning leading to congruent, that means that they will be equidistant. That tells us that this measure right here is going to be 3. We also know that if we were to continue this out, we would have a diameter, and it would be perpendicular to a chord. Any diameter that is perpendicular to a chord is going to cut the chord. It's going to be a perpendicular bisector. So that means it will cut the chord in half. So now we have a right triangle where we have legs 3 and 5. We'll use the Pythagorean theorem to solve for x, keeping in mind that when we do a squared plus b squared equals c squared, c is always going to be the hypotenuse, which is x. So a squared and b squared, it doesn't matter which leg you choose for each. So 3 squared plus 5 squared equals x squared. So 9 plus 25 equals x squared. So we get 34 equals x squared. So x will be the square root of 34. And if we're trying to simplify, we can say the square root of 34 is 17 times 2. 17 is prime, so there's nothing further we can do, and this will be our answer.